and I'll go ahead and draw that in with the animation here, okay? So anything here is 95 degrees dry bulb, here is 95 degrees dry bulb, here is 95 degrees dry bulb, so on and so forth. Okay, I think you get it. So what about 70 degrees dry bulb? Let's find 70 degrees dry bulb, which is right here. Okay, so you see the little line that comes off of it here? So we're going to draw that line up. That does a much better job than me trying to draw it. And anything along this line is 70 degrees dry bulb. Okay, even all the way up to here. Okay, so that's the dry bulb lines. Now let's look at the next thing here, which is wet bulb. Okay, so 70 degrees wet bulb. So our wet bulb temperatures are on this curve here. Okay, so it starts down here, looks like 20 degrees wet bulb, and it goes, let's see, there's 80, 85, 90, and 95. I think that's a wet bulb there too. Okay, so we're looking for 70 degrees wet bulb. So 70 degrees is right here. So now what happens here is you find the closest diagonal line that connects with it, which is right here. Let me draw that in with the animation. There you go. So you just draw in this line. So if you're following along and have a straight edge, you could draw that line across there. So what happens is anything along this line represents 70 degrees wet bulb. Or wet bulb, excuse me. Okay? Okay. Now the next one here is 55 degrees wet bulb. So again, the wet bulb is located here on this curve on this chart. And here is 55 degrees wet bulb. So if we go ahead and draw that in, it looks like that. So anything along this line is 55 degrees wet bulb. Okay. Last one here is dew point, which is 60 degrees. Now on this chart, the dew point temperatures are over here. Some charts, you won't have a dew point temperature here. It'll be over on this side somewhere. We'll talk more about that in one of the other courses, but let's not get off track here. So, okay, so 60 degrees is right here. And always be careful not to be confused with the humidity numbers, which is grains per pound of dry air, which is right here, because they're kind of close. These numbers are kind of close. Okay, so 60 degree wet bulb, 60 degree dew point is a horizontal line that goes across. So let's draw that in. Boom. So anything along this line is 60 degree dew point. All right. Okay, let's move on and look at some other numbers here. Okay, now let's draw some relative humidity curves. So I've got two properties here, 50% relative humidity and 20% relative humidity. Now remember, these are curves on the chart, and they are located right here. So you can see this says relative humidity. There's 10%, 20%, 30%, 40, on and so forth, up to 100% on the saturation curve, which we'll talk about in a minute here, okay? So if we want to find 50% relative humidity, it is right here, okay? And there's the 50% relative humidity curve. So I didn't draw the whole thing in, but if you were to follow this all the way up here, this would be 50% RH, 50%, 50%, and you kept going down here, 50%, all the way down to here. Okay, so anything along that curve represents 50% relative humidity. What about 20%? Okay, so 20% is right here. I don't know if highlighting those numbers helps or makes it impossible to see. I can't tell. But anyway, that's 20% there. And that is a 20% relative humidity curve. So anything along this curve here, getting better at my X's here, represents 20% relative humidity. Okay, what's next? Okay, so let's locate two constant enthalpy values, okay? So enthalpy is expressed in BTUs per pound of dry air. We're going to look for an enthalpy of 20 BTUs and an enthalpy of 40. So enthalpy is located here and here. And you see you have these numbers, 10 up to 50 here, and it also goes up here. Okay, so what you do is you match these numbers up with the correlating enthalpy on this axis here. So let's say we wanted 20 BTUs of enthalpy, BTUs per pound of dry air. We would take our straight edge, line it up with this number, line it up with this number, and then boom, you would draw that in. And anything along this line represents a 20 BTUs per pound of dry air enthalpy. All right, how you feeling? Looking pretty easy? I hope you're getting the hang of it. I hope this helps. So 40 BTUs per pound of dry air. 40 is right here. And 40 is right here. So go ahead and line that up with your straight edge. And then boom, you are good to go. Okay, enthalpy, pretty easy. Let's see what's next. Okay, we're going to talk about something that's important, which is the saturation curve. Okay, the saturation curve is located right here. It's the 100% relative humidity line. It's also called the saturation line, the saturation curve. You know, all are acceptable and correct in the terminology of our day-to-day work. So what this means is the air on this line cannot hold any more moisture. Okay, like when you're doing a cooling coil process on a psych chart and you're going from right to left, so you're cooling, you'll notice the curve starts to dip down the closer it gets to the line there. Let's see how it did. Not so much of a curve, but I think you get the idea. So you're moving this way. As you get closer to the curve, the water starts to drop out of the air and it lowers the humidity in the air. Okay, so your 100% saturation curve is located right here. And I forgot to put the note in there. Boom, 100% saturation curve. Okay, I hope that helps. That's about 9 or 10 minutes of the chart. And on the next few cards, you're going to see a breakdown of each of these examples and get your chart and play around with it for yourself. See how you could do.